Hi class, this is lesson 10-2, find arc measures. So we're first going to look at some vocab. It says identify the following parts of a circle. First it says central angle. So I'm going to put underneath this what the definition is. A central angle is an angle whose vertex is the center of the circle. That's what a central angle is here. So I'll draw one in here in green. This would be a central angle because the vertex is right there at the center of the circle. So my example is angle COB, or we could say that's angle BOC as well. The next one, a minor arc. A minor arc is an arc formed by an angle that's less than 180 degrees. So if you look, this angle right here, that's less than 180 degrees. So this arc along the outside of the circle, that would be called a minor arc. So this in red is a minor arc. And we could label that arc BC. A major arc, I'll do that in a different color again. A major arc next. So a major arc is an arc formed by an angle that is greater than 180 degrees. So if I start here at C and go all the way around to point B, this right here, that would be a major arc. And I would label that one arc, and my two endpoints are B and C, so I'm going to have to put the B and the C in there, and then I'll have to put another point that's on that arc in between them. So I could use A or D. I'll just put A in there, arc BAC. That's one way I could label that arc. Semicircle. Okay, a semicircle is an arc with endpoints at the diameter. So here in orange, this would be a semicircle. So that would be arc AC. That would be a semicircle because it's the angle is really 180 degrees. So it's halfway around the circle. So let's look at the measuring arcs part here. It says the measure of a minor arc is the measure of its central angle. The expression, the measure of arc AB, so this is right here. This is red, the measure of arc AB. That's what the little M is. So the measure of the entire circle, all the way around, all this arc all the way around, that's 360 degrees. Just like the angle, total angle degree of a circle. The measure of a major arc is the difference between 360 degrees and the measure of the related minor arc. So the measure of a semicircle is always going to be 180 degrees because I said a semicircle is halfway around a circle. So in this example, here is a minor arc, arc AB, and that's 50 degrees. So to find the major arc, which I'll put here in green, that's arc ADB, all around the outside. To find the value of that, we do 360 degrees minus the minor arc, so minus 50 degrees to get our 310. So right here it says minor arcs are named by their endpoints. We use 2 points. Major arcs are named by their endpoints and a point in the arc. So we use 3 points to name those. All right, so let's do this example here. It says find the measure of each arc where segment DF is a diameter. Since we know segment DF is a diameter, right here, segment DF, that's a diameter. We know halfway around is 180 degrees. So first it says we want to find the measure of arc DE. So arc DE, well, that's this angle right here. So that arc DE is 117 degrees. Now we want the measure of arc DFE. So arc DFE, since there's 3 letters there, we know it's going to be this major arc. So we're going to do 360 minus this 117 that's not included. So do 360 degrees minus the 117 degrees of the minor arc that's related. That's 243 degrees. It's the measure of that major arc. So the next one, it says arc DEF. So DEF, well, that's going around to the diameter. That's a semicircle, so it's 180 degrees. Try that on your own. Pause it, and then see if you can get it right. Okay, so this on your own problem says find the measure of arc RTS. So RTS, we want all of this arc out here, so we do not want this 45 degrees. So in order to do that, we're going to do 360 degrees minus the 45 degrees that we don't want, and that's 315 degrees. Postulate 23 is the arc addition postulate. So the measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. So if we have 2 arcs that are next to each other, we can add them together to find the sum, the total. So it says the measure of arc ABC equals the measure of arc AB plus the measure of arc AC. We can add those 2 smaller arcs together to find the value of the larger arc. And let's flip the page. So example 2, it says you join a new bank and divide your money several ways as shown to the right. Find the indicated arc measures. So the first one, it wants a measure of arc BD. So BD, now there's only 2 points, so we're not going to come around this way. That's a major arc. We're going to have to come this way. So we're going to have this 55 degrees plus this 105 degrees. So we're going to say 55 degrees plus 105 degrees, and that gives me a total of 160 degrees. B says the measure of arc BCD, so he's got to start with B, go through C, and then hit D. So we're looking at these 2 pieces right here. That's a major arc, so it should be more than 180. So our 2 pieces are 140 degrees plus 60 degrees. And if you add those up, you find it's 200 degrees. So try the on your own. Pause it and try it. Okay, in example 2, find A, the measure of arc BCA. So arc BCA, and we know we're going to go around this way because it's a major arc. If we went this way, that'd be a minor arc. So it's all 3 of those pieces. So we're going to say 140 degrees. This is A, 140 degrees plus 60 degrees plus 105 degrees. My total there is 305 degrees. So for part B now, it says the measure of arc ABC, and again, that's a major arc. So A, B is now in the middle, and then there's C. So we want this arc, so we're going to add these 2 pieces. It's going to be 55 degrees plus 140 degrees for a total of 195 degrees. Okay, let's talk about some congruent circles. So move this up a little bit. It says right here, 2 circles are congruent circles if they have the same radius. 2 arcs are congruent arcs if they have the same measure. So they have to have the same measure, and they are arcs of the same circle or congruent circles. So the circles have to be the congruent circles or the same circle in order for us to know that the arcs are the same length. So example 3 says tell whether the given arcs are congruent, explain why or why not. So A says arc BC and arc DE. So arc BC is right here, that's 75 degrees. Arc DE is right here, that's 75 degrees. So they're congruent and they're on the same circle. So yes, the 2 arcs are congruent. So both are 75 degrees and on the same circle. B says arc AB. So arc AB would be this. That's 80 degrees. And then arc CD would be this arc right here. Now that one's also 80 degrees, but they aren't on the same circle. And you can tell that one of the circles is obviously larger. So our answer, no, they're not going to be congruent. And that's because the circles aren't congruent. C is arc FG, which is right here. We don't know that, well, that's a right angle, so it's 90 degrees. And then arc HJ is right there. That's also 90 degrees. And if you notice, right here we have one marking, and right here we have one marking, so that tells us this length and this length are the same. So the circles have the same radius, so they're going to be congruent circles. So, are the arcs congruent? Yes. Both are 90 degrees and on congruent circles. Pause the last one and try it. Says on your own in the diagram at the right is arc PQ congruent to arc SR. So arc PQ is right here. Arc SR is right here. Now we've got these little markings saying that those two are congruent. So we don't know what the angles are, but we know they're congruent. And they are on the same exact circle. So since they're congruent and on the same circle, we can say yes. The angles...
Hey, you got your husband.
Sorry, that's my husband. The angles are congruent. And on the same circles. All right, this is the end of lesson 10-2. Make sure if you have any questions, you ask me about it in class tomorrow, and have a great night.